Mathematics. So first notation. These are the notations for different operations. Vector and matrix, scalar product, vector product, and this cross product dotted with a cross product. So A dot C and B dot D minus A dot D B dot C. So A dot B cross C can be written in that determinant form. It indicates the volume of the parallel pipe. Vector triple product A cross B cross C. So this it will be component of B vector and C vector. So A dot C with the B vector minus A dot B with C vector. Common three-dimensional coordinate system, that is x equal to r sin theta cos phi. So this is r. So this is r cos theta. This is r sin theta. Sin theta now phi. So r sin theta cos phi and r sin theta sin phi. So these three components. So for rectangular xyz, for spherical r theta phi and cylindrical rho phi z. So dx dy dz and the volume element is r square sin theta dr d theta d phi, and here cylindrical rho del rho del z del phi, and the h metric elements is 1 1 1 for rectangular, 1 r sin theta for spherical polar, and 1 rho 1 for cylindrical coordinate system. For gradient, we know for spherical polar coordinate, for rectangular coordinate system, the general formula for that is q vector divided by h1 times df dq1, q2 h2 df dq2, q3 h3 df dq3. Divergence again, rectangular coordinate system, we know for any general orthogonal coordinate system, 1 by h1 h2 h3 multiplied with d dq times a. So first term will be changing, so a1 h2 a3 will fix, next one a2 will change, so h1 h3 will remain, and third one a3 will change and h1 h3 will remain. For curl we can write in the determinant form x cap y cap z cap del x del y del z ax ay az. So more general expression, 1 by h1 h2 h3, earlier also 1 by h1 h2 h3 for divergence. Here 1 by h1 h2 h3 times first term q1 h1 q2 h2 q3 h3, then the derivative term, and then h1 a1 h2 a2 h3 a3. Radial form, first gradient of a radial gradient of r is r vector by r. Our divergence of r is 3, divergence of r square is 2r vector, divergence of r times r vector, that is 4r. That we can do simply just breaking this r vector into two parts. So similarly also just breaking these vectors, we can write down this expression. So divergence gradient of 1 by r equal to minus r by r cube. Divergence of r by r square is 1 by r square. Gradient of 1 by r square is minus 2r r to the power 4. That three formula we don't have to remember, we can derive this. Only thing to remember is divergence of r by r cube. Divergence of r by r cube. So this is 4 pi delta r. So rather than at r equal to 0, the formula will give 0 only. Laplacian divergence, Laplacian of f equal to del f. This formula we know, there is a double derivative of every components. So differential operator also will distribute, this will follow distributive laws, and the important one is the gradient of a scalar product. It will contains all the cross terms, a cross curl of b, b cross curl of a, times again a dot grad b, again b dot grad a. So gradient of a scalar product, it will contains all terms, it will be positive, and it will have cross product and cross b, a cross curl of b and a, and also a dot grad b, like these terms. So next is the divergence of a cross product. It will have only two terms. So first term that will remain, that will be b dot curl of a. So first term will be b dot curl of a minus a dot curl of b. Again curl of cross product, it will have four terms but with a minus sign change here. So first term that we will see, that the contribution of a will give positive sign, so vector a. So other terms will shuffle, that will be divergence of b and b dot grad. For b it both will be minus, so minus b divergence of a times b a dot gradient nebula. So divergence of a gradient is a Laplacian. Curl of gradient is 0, divergence of a curl is 0, curl of a curl is nebula divergence of a minus nebula Laplacian of a. Vector integrations, we have Gauss divergence theorem. If we have a divergence and the integration over the volume, then it will transfer to surface integral of that vector. Stokes theorem, if we have curl in a surface integral, then it will transfer to line integral of that vector. And Green's first theorem, second theorem, that will just break down these formulas into other terms. So f grad g dot ds, so that will be transferred to volume integral with a divergence. So this formula it will follow, and then we'll just use distribution law to get the final form. So we don't have to remember that. So matrix algebra, we have transport, that is easy transpose of elements will shuffle, j to I and I to j, it will be same. Hermitian matrix, that is important. So h dagger equal to h dagger indicate the adjoint of the adjoint, that indicates transpose of conjugate. Now unitary matrix, all these are basic things. Commutators, a comma b equal to ab minus ba, adjoint a b dagger equal to b dagger a dagger, the distribution property, associative property, Jacobian identity, that is a comma b comma c plus, we can write like this, a comma b comma c plus b comma c comma a plus c comma a comma b equal to 0. This is also Jacobian identity. Pauli matrix, first element is sigma 1 is 0 1 1 0, sigma 2 0 minus I 0, sigma 3 1 0 0 minus 1, and the fourth element is the identity matrix. So the property of Pauli matrix is trace 0, determinant minus 1. So the anti-commutation relation sigma I sigma j plus sigma j sigma I equal to 2 delta I j. This is the relation. And cyclic permutability I equal to sigma I sigma j equal to I sigma k. Sigma square equal to 1 always. Rotational matrix, rotation about x-axis, so it will be 1 0 0, 0 cos theta sin theta, 0 minus sin theta cos theta. Rotation about y-axis, so this y-axis term will be 0 1 0, other terms will be 0 cos theta sin theta, 0 minus sin theta cos theta, like that. X3, so this term will be 0, so cos theta sin theta minus sin theta cos theta. So after 1, the first term will be cos, second term will be sin. Here also after 0, first term will be cos, second term here will be sin theta. That goes to that part here. Series and summation, arithmetic summation, Sn equal to n by 2 2a plus n minus 1d, or n by 2 a plus l. L is the last element. Geometrical progression, Sn equal to a plus ar square plus a r to the power n minus 1. So a times 1 minus r to the power n divided by 1 by r. So if r, the value of r is less than 1, so we can, this term we can ignore. So 1 by r, and n is very large, so n is very small value, r is very small value. In that case we can ignore that term and it turns to a by 1 minus r. Arithmetic mean is the mean of average geometrical mean multiplication of n terms with a 1 by square root of to the power 1 by n. This is the geometrical mean. Harmonic mean is the 1 by 1 plus x1 plus 1 by x2 plus 1 by x3 1 by n. This is the harmonic mean. So now some summation formula, 1 plus 2 plus 3 plus first term, it will give n into n plus 1 by 2. This is the first term. If we have 1 square plus 2 square plus 3 square so n by 6 times 2n plus 1 into n plus 1, this term. So if we have 1 square, 1 cube plus 2 cube plus 3 cube, like that, so n times n plus 1 by 2 whole to the power square. So similarly, if we have I to the power 4, we have n by 30, n plus 1, 2n plus 1, 3n square plus 3n minus 1. ln2, the value of ln2 is 1 minus 1 by 2, half plus 3 by 2 minus 4 by 2, like that. ln2, that is. So pi by 4 we have 1 minus 3 by 1 by 3 plus 1 by 5 plus 1 by 7 minus 1 by 7, like that. Pi square by 6 we have 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus So it will be pi square by 6. Now power series, binomial expansion, 1 plus x to the power n. So this will be 1 plus nc 1 time x to the power 1, 1 to the power n minus 1 plus nc2 x to the power 2, 1 to the power n minus 2, like that. So this is the binomial expansion. CR NCR equal to n factorial by r factorial minus n minus r. Binomial theorem, a plus b to the power n is the NCR, a to the power n minus k, b to the power k, and k is 0 to n. Taylor series, f of a plus x, that is f of a plus x, first derivative of f at x equal to a plus x square by 2 factorial, second derivative of f at x equal to a, like that. Taylor series in 3D, so f of a plus x equal to f of a is a vector, so x dot nabla f at a plus, like that, x dot nabla square by 2 factorial f at x equal to a, like that. Maclaurin series is the when we expand the series around 0. So f of x equal to x f of 0, x time f first derivative at 0, x equal to 0, second derivative times x square by 2 factorial at 0, like that. So limits n to the power c x to the power n as x is less than 1, mod of x is less than 1. So in that case, when n tends to infinity, it will go 0. Again, x to the power n by n factorial goes to 0 as n tends to infinity. 1 plus x by n to the power n tends to e to the power x as n tends to infinity. X ln x tends to 0 as x tends to 0, as this ln x, increase of ln x is lesser than x, increase of x. Sin x by x is 1. Some known series, e to the power x, 1 plus x square by 2 factorial plus x cube by 3 factorial dot dot dot. Ln 1 plus x is x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 plus other terms. Ln 1 plus x by ln 1 minus x, that is 2 times of x plus x cube by 3 plus x to the power 5 by 5 plus x to the power 7 by 7 plus dot dot dot. And cos, it is 1 minus x square by 2 factorial, x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial. For sine, we have x minus x cube by 3 factorial, x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial and other terms. For tan, we have x plus x cube by 3 plus 2x to the power 5 by 15 plus 17x to the power 7 by 315. Similarly, other formulas are there, but important, arc sine, so sine inverse x equal to x plus 1 by 2 2x cube by 3. So 1, 2, 3, 4, 5 x to the power 5, 1, 2, 3, 4, 5, 6, 7 x to the power 7, all are positive. Cos hyperbolic of x, every term is positive, but in case of cos, normal cos, we have first term positive, second term negative, third term positive, fourth term negative. In case of sine hyperbolic, every term also positive. For tan hyperbolic, earlier we had all term positive, 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 but here in that case, this is negative. Positive, negative, positive, negative, like that it will follow. Inequalities, triangular inequalities, summation of individual subtract difference between two individual terms is less than the summation of the terms and also lesser than the individual sum. So this is triangular inequality. Cauchy inequality is the multiplication and then summation and then taking square, that is smaller than individual summation square. Complex integral, z equal to x plus iy, polar form, z equal to r e to the power I theta, modulus mod of z equal to r, z1 z2 is mod z times mod z2. Argument theta equal to tan inverse of y by x. Arguments we can just simply add between two some multiplications. Complex conjugate z star equal to e to the r to the power e to the power minus I theta. So logarithm ln z equal to ln r plus I theta plus 2 pi n. So for different n's we will have values of theta, same z. Complex analysis, Cauchy-Riemann equation. So if fz will be analytic when ux equal to vy and uy equal to minus vx. These two formula. Cauchy theorem. So contour integral will be 0. Cauchy formula, f of z equal to 1 by 2 pi I contour integral f of z by z minus z0 dz. Cauchy formula. For n times n derivative, in case of n derivative, n factorial we have to multiply and the order at the bottom will be n plus 1. Residual theorem. So contour integral will be 2 pi I times n close of residue. Trigonometric and hyperbolic formulas. Sin theta, cos theta, tan theta formula, it is common. So now these are also known. Hyperbolic relations, sin x plus y, that will be sin x, sin hx, cos hx, hy plus cos hx, sin hy, like that. Plus minus minus. Here also plus minus plus minus, plus minus plus minus, plus minus. So here this formula is interesting. So cos hyperbolic square x minus sin hyperbolic square x equal to 1. Now trigonometric to hyperbolic, e to the power in equal to cos x plus I to the power I sin x to the power n. That can be expressed. This n can be put inside. So like this. This is called Moivre's theorem. So cos x, sin x, cos hx, sin hx. Again this cos ix, cos hyperbolic x, sin ix, I sin hyperbolic x. Like that, this inversion can be calculated. Thus hyperbolic functions. So mensurations is the in Mori fringe. In case of parallel pattern, we have dm is the Mori fringe spacing is 1 by d minus 1, 1 by d1 minus 1 by d2 to the power minus 1. In case of Morbin free spacing due to rotation, then d by 2 sin theta by 2. Plane triangle, sin formula a by sin a, b by sin b, c by sin c, and a square equal to b square plus c square minus 2bc cos a. That formula again, cos a, that can be written like this, and this a can be written as b of cos c plus c of cos b. Again area half ab sin of c. Area can be written for any triangle s times s minus a, s minus b, s minus c to the power half. S equal to mean of these values, mean of the perimeter, half of the perimeter. For spherical triangle, sin a by sin a, sin b by sin b, sin c by sin c. Perimeter of a circle 2 pi r square for circle area. A surface area of a square 4 pi r square. Volume is 4 by 3 pi r cube. And area of a ellipse pi ab. Volume of a ellipsoid 4 pi by 3 abc. Like this, other formulas are also here. Conic section. So this is parabola. So y square equal to 4x. This is ellipse, x square by x square plus y square by b square equal to 1. Hyperbola, x square minus a square minus y square minus b square equal to 1. So eccentricity is 1 for parabola, and this other focus and parametric forms can be shown like this. So in differential geometry, curvature, radius of curvature equal to 1 by kappa. Kappa is the curvature that can be calculated using that. Derivatives, power, product, quotation, quotients, functional form, Leibniz theorem, n times derivative. We can do like nc0 v first term n times, again nc1 first derivative, and the rest of this in minus 1 time. Like this we can proceed. Trigonometric derivatives, sine, cos, tan, cosec, sec, cot, and the sine inverse, cos inverse, tan inverse, cosec, sec, cot. The hyperbolic derivatives, sine will become cos, cos will become sine, no sign change. Partial derivatives, the multiplications of all dg dx, dx dy, dy dg will be minus 1. The reciprocity formula. Now Jacobian, delta xyz, delta u xyz, that can be written like the determinant form. The change of variable, we need that Jacobian. Stationary points. So del f del x equal to 0, del f del y equal to 0. Maxima when the value of second derivative will be less than 0. Minima when second derivative is greater than 0. Saddle point when delta f delta x2 delta 2 delta y2 is less than delta 2f delta x delta y square. Differential equation, Laplace equation, diffusion equation, Helmholtz equation, wave equation, Legendre equation, associate Legendre equation. Here we have minus m square by 1 minus x square. Bessel equation, Hermite equation, Laguerre equation, associate Laguerre equation, Chebyshev equation, Euler equation, Bernoulli equation, and Airy equation. Integration, this is integration by parts, this is basic formulas. Now trigonometry and hyperbolic integral is also known. So cos hyperbolic integration or sin hyperbolic integration, it will not change sign. So named integral, error function, and all other phases integral, gamma function. So gamma function is important. Gamma 0 to infinity e to the power x minus x e to the power minus t dt. Define definite integral e to the power minus alpha x square equal to square root of pi a. If the integral is from minus infinity to plus infinity, with minus ax square. Here we have 0 to infinity, so we have half. Then special functional polynomial gamma function definition. gamma equal to this. So gamma n plus 1 equal to n factorial. Gamma half is square root of pi. Then Bessel function, Legendre polynomial, associated Legendre polynomial. This is the solution for it. Spherical harmonics, differential equation definition, or orthogonality, Laplace series, solution of Laplace series. These are the different forms. Delta function, delta I 3. This is Levi-Civita symbol. Dirac delta function and its properties. Minus even root of a quadratic and cubic equation. So we know this formula, but we can also write x as minus 2c by b plus minus square root of b square minus 4ac. Solution combination x1 plus x2 equal to minus b by c. x1 times x2 equal to c by a. Cubic equation, this is pqd we have. So whenever d is 0 or greater than 0, we can have u, v, and u1 will be u plus v, and u2, 3 equal to minus u plus v by 2 plus I u minus v by 2, 3 to the power half, like this. When d is less than 0, then we will have that solution. So these are the solutions. Combined solution x1 plus x2 plus x3 equal to minus b by a, and multiplication of 2 terms will be c by a, and multiplication of 3 terms will be d by a. Now Fourier series fx equal to a by 2 summation over n from 1 to infinity an cos n pi x by l plus bn sin n pi x by l. So an can be calculated 1 by l integration minus l to l f of x multiplied with cos of n pi x dx. Again bn will calculate 1 by l f of x times sin of n pi x l by l dx. Complex form, we can write e to the power I n pi x by l, and cn can be calculated 1 by 2l minus l to l f of x e to the power minus n pi x by l dx. Parseval formula 1 by 2l px square dx equal to a0 by 2 whole square plus half of an square plus bn square. Fourier transform, we can use all of these three different definitions. So in the first, we don't have coefficient at the beginning, rather we have added 2 pi in the power. So if it is the Fourier transform, this is inverse Fourier transform. So if we add 1 here, we have to put 1 by 2 pi. If we put 1 by 2 pi root over 2 pi, we have to put 1 by root over 2 pi here at the next time. Fourier transform theorem, convolutions f of x gx equal to fu g of x minus u integration over du. Convolutions rules are like this. Convolution theorem, g of f of x times g of x equal to capital F of s g of s. Autocorrelation functions like this. Wigner-Knighten formula f star x fx equal to fs square, and Parseval relation fx gx square equal to fg fs gs. Parseval theorem, derivatives f of x dx is the 2 pi I s times f of s. Fourier symmetry, if fx is even, that will be even to even, odd to odd, real even to real even, real odd to imaginary odd, imaginary even to imaginary even. complex event to complex event, and like this. Fourier transform pair. So normal f of x transferred to f of s. F of x is goes 1 by mod of a, f of s by a. F of x minus a, it will add e to the power minus 2 pi I as. Derivatives n times, then 2 pi is to the power n. Delta will gives 1. Delta x minus 1, it will give 1 times e to the power minus 2 pi I as. E to the power minus a mod x, it will give 2a by a square, 4 pi square s square. This Gaussian, it will also give Gaussian. Like this, we will get this Fourier transform. Laplace transform definition: 0 to infinity f of t e to the power minus st dt. Convolution, multiplication of them will be Laplacian of individual multiplication of the elements. Inverse will be 1 by 2 pi with power gamma minus I infinity, gamma plus I infinity, the sum of residue. Laplace pairs: ft goes to fs, dt delta function goes to 1, 1 goes to 1 by s, t to the power n goes to n factorial by s to the power n plus 1, t to the power half goes to root over pi by 4 s to the power 4 s to the power 3, t to the power minus half goes to pi by s, e to the power at goes to 1 by s minus a, t times e to the power at goes to s 1 by s minus 1, like that. Sine goes to a by sine s square plus s square, cos s by s square plus s square. So one formula, e to the power minus at, it will shift the origin only. Probability of statistics: mean, variance is the difference from mean square of the average. Standard deviation is the half of the square root of variance. Skewness, kurtosis, correlation coefficients. Discrete probabilities, binomial distribution, we have already seen. The mean is np, variance is np times 1 minus p. Geometric 1 minus x to the power 1 minus p x to the power n minus x minus 1 times p. Mean is 1 by p. Variance is 1 minus p by p square. Poisson distribution, we have mean lambda, variance also lambda. Continuous probability distribution, exponential distribution, we have 1 by lambda mean, 1 by lambda square variance. Normal distribution, we have mu mean, sigma square variance. And others. Random walk, we have probability, the Gaussian distribution, then XRMS equal to square root of n to the power half times L, it is the length of the steps. Numerical methods of straight line fitting. So model y equal to mx. Now we will use different parameters here. So am we will get like this, and intersections will be c will like this. Now numerical integration, topological rule, h by 2 will be divided into smaller parts of h, f0 plus f1, h by 2 f0 plus 2f1 plus 2f2, like that. The end term will be only fn. Simpson rule, h by 3 f0 plus 4f1 plus 2f2 plus 4f3, like that, plus 2 again 4 again 2 plus 4. The last term also will have one coefficient. Numerical differentiation, like this. Double derivatives, we will have this double derivative like this. Numerical solution, second method, x next steps xn plus 1 equal to xn minus x minus xn minus 0 f of x minus f of x minus n to the power times f of xn. Newton Raphson to get the numerical solution, like the roots f of x equal to 0 when the cuts happen. So again f of x x n plus 1 equal to xn, f of x f of xn divided by f dash xn. Euler method to do numerical ordinary ODE solutions. So h equal to the difference between two successive positions, y equal to y plus h f. RK2 Rangagita fourth order, same equation, k1 equal to h f, k2 equal to h of f, but x plus h by 2, y plus k plus y plus k1 by 2, k3 f h f x plus h by 2, y k2 by 2, k4 h f x plus h k y plus k3. So yn plus 1 equal to yn plus k1 by 6, k2 by 3, k3 by 3, k4 by 6.